Welcome to the Continuous Improvement Podcast, Incremental. I'm Devin Bedoni of Like and Precision.
And I'm Uriel Eisen of Austere Manufacturing.
And this week we are going to do a little discussion of rationalization of production. If you know what that is, you're ahead of nearly all of us, including myself, really. A quick overview of TPS Toyota Production System Engineering methodology, which we kind of hinted at last week but didn't get into. Also a teaser on some cognitive load research that Uriel dove into this last week. A little more in-depth discussion of single-piece flow for people who are new to the concept or just want to know a little bit more about it, why, kind of the ins and outs, at least from our perspective, of why it's beneficial. And then we're going to go over each of our weekly improvements this last week, and then kind of a deep dive like the Tumblr discussion into some problem solving of my software data management goals/issues.
And whether to develop something in-house or buy something off the shelf, and sort of how to think about that based on sort of what we've read and what we've experienced, I guess.
Relative merits of either. And then before we dive in, I just wanted to do another mention, just that continuous improvements, improving your system, obviously is not something unique to Lean or Toyota Production System. This is something that we all do. Yeah. We all have done. The thing that both Uriel and I have come away from this reading and just thinking is that what Lean thinking, Toyota Production System thinking brings to the table is a systematic and scientific approach to analyzing and doing those improvements that's fairly unique, I think, in the world of manufacturing. Obviously, manufacturing since the early 1800s really has been a steady process of improvement.
I mean, even before, right?
Even
all those
before.
Tools that someone built.
Sure. Yeah, it has.
The loom wasn't here when we started. So.
Yeah, we are. I think improving your processes is a human thing.
I think that's important to mention. And I mean, for me, I think beyond just the system, I think the being able to read about a company that's been doing it for many, many years at this point and seeing the results they've had, I think gave me a little bit more confidence that it is a good use of time.
Yeah.
And I mean, that's still an ongoing debate, I think, about how much time one should spend on it. And it is tricky to balance.
Probably not. There is probably no rule. Just like it
depends when.
Yeah, just like this whole thing is not it's not a toolbox. I think it probably goes up and down depending on where your processes are, what you do,
sales,
all of that.
Yeah. So I'm rereading the Toyota Way actually for like the 10th time or whatever. I feel like every time I read these books, even if it's again, I'm just at a very different place and just like taking a lot more or different stuff or something. And I think part of why we wanted to start this podcast earlier rather than later is it's really interesting, I think, to hear that process of like an early understanding and like why you're wrestling with these concepts. So one of the concepts when I first read this book and up until now, that really kind of just got under my skin right at the beginning. He's sort of like, TPS is not about reducing waste. And I'm like, wait a second. Like after reading all these books, that was the one thing I thought it was about. And I think what I'm finally realizing, and maybe this is incorrect, but what I took away from it this time is that because of the context of that chapter, Toyota had certain problems, as you sort of alluded to, I think, in episode 1, right? Toyota had certain problems that they talk about, right? They didn't have much space. They didn't have much capital. They didn't have much equipment.
Yeah.
They needed to make money.
They were like an upstart company by all accounts.
Yeah. And so I think what's really unique about what they did was bringing this incredible level of like perceptiveness and attentiveness to like, and getting rid of sort of preconceptions about how one should achieve their thing.
Sure.
Or making cars in their case. And really just an ability to like zoom out and look at the entire process, and then see their problems and then try to figure out ways of dealing with their problems. And I think what we're seeing is the result of doing that for the past 70 years.
70, yeah.
Um,
Or ish.
and so that's like a real treat for the rest of us. It's like, oh, they use Kanban, I'll do Kanban, right? Oh, they do whatever, I'll do that. And so I think it can, like, I don't think mimicry is entirely a waste of time necessarily, right?
Yeah.
Like that's how I got into it, was implementing certain pieces of it and then realizing that that highlighted other problems. But I think their point is that, and something we've been talking about a lot, is it's not a one size fits all. And the second you treat it as like, oh, we're doing Kanban and we're doing 3S or 5S and we're doing all these things that you can read about that Toyota does, like you've lost your way. And the way back is to really think hard about what are your challenges, like what is what is hard about your business, and maintaining an open enough mind to rethink really fundamental parts of your business, I think.
Yeah.
And so like they talk about rationalization as one of the important aspects, like one of the really foundational aspects of production under the Toyota production system, TPS, is this idea of rationalize your production, which I have to say I've been reading about for 2 years now and just literally had no idea what that meant.
Yeah, I mean, it's like, okay,
sounds
cool.
I'll do that. I don't know.
Rational is great.
Yeah. So I think it's sort of this thing we're all doing all the time, but not doing enough, which is, and we were talking about this in regard to my Tumblr problem, is really zooming all the way out and saying, what are we trying to achieve? What are all the different ways we can achieve it? And what is the most rational one? And you can't, like, you know, I remember there was a chapter where they were talking about, like, if you can eliminate the need for one person on a line by spending $500 on an improvement, that is a huge win. However, if you can eliminate the need for that same person by just rearranging your equipment and spending $0, the rational conclusion is that $500 is all waste, right? And so I think that's sort of like rationalization. Like we had a lot of rejects in paint. And one of the things we did is slow down our painting process, because we realized, we counted up how many rejects we had. We said, this is this amount of lost revenue per month. We have a huge time budget to fix this problem and still have a total reduction in cost of goods. Whereas I think it's really easy to be like, well, we can't slow down paint because then we're going to have to increase our cost of goods, because we're counting on it only taking whatever X number of seconds per part.
Right. In your ideal scenario, like it's going to be this time, and this time costs this money. And
and we've calculated all that, so we can only speed up from here. But it's like, but you're passing on a bunch of rejects that then get cut. So I think that's sort of the rationalization piece, I think, is just like really looking at what you're doing. Do I need a fast machine? Probably not. What if I ran a slow machine all day? Or what if, like, if I do production leveling, which is one of their other pieces, turns out you don't need fast machines, and they really lose their, like, there's no reason to have a fast machine. And in fact, you should slow down a fast machine in many cases. And that just seems so counterintuitive when you're just looking at, like, seeking a local optimum, which is like a critical chain theory. It's sort of like, don't seek local optimum, right? I think it's a lot about kind of that.
Yeah, it kind of comes back to the ask why 5 times. It's like, don't find, like, there might be an obvious answer and you may want to fix that, but there's probably an underlying problem underneath that. And then there's probably an underlying problem underneath that. And, they say,
go 5
deep, which if you do that on everything, it's pretty fundamental.
One of my favorite examples of that, briefly, was I think it was in the Toyota way. Toyota had a tier 1 supplier that was giving them bad parts, and off of this one machine that couldn't hold tolerances. And so they were sort of saying, in the book, most companies would say, go buy a new piece of equipment because this thing is out of spec. They asked why 5 times, and why is it out of spec? Because, or whatever, I forget the whole series, but it came down to the job was not engaging enough to retain operators. And so they had such high turnover that the training, because it was just a hard tolerance to hit, and there was a certain way of doing it. And so they were constantly training people, because there was high turnover. And so they
Interesting.
changed how you do the work there and combined it with another station, if I recall correctly,
Huh.
to make it more interesting, increasing retention. Didn't have to buy a new piece of equipment and fix the problem.
Very interesting.
Yeah. So that's like, I don't know. Yeah. Go deep.
Yeah, really. That's super deep. And also cool to, I don't know. I just feel like they're amazingly good at bringing the human aspect back into like everything that they look at. And it's so easy to focus on machinery and
Yeah.
focus on
And that
like
wasn't even
hard
their
problem.
spend, right? That was one of their suppliers would have had to pony up the cash for that.
Yeah.
But it also wouldn't have fixed the problem.
Right. Yeah. And it's just amazing to be like, oh, y'all are bored. Let's make this more interesting.
We have a really high turnover. So,
Yeah.
a quote I read that I thought was really nice that's attributed to Aristotle.
Yeah.
But I Googled it and it's not from Aristotle. But it says, "We are what we repeatedly do. Excellence, then, is not an act, but a habit."
Yeah.
I don't know. I just feel like it really ties into what we're talking about here, which is like an ongoing process of getting a little bit better.
Yeah. I like that reminds me of a quote that I heard from a rowing coach when I was rowing. I don't think I've mentioned this on the podcast, but rowing is obviously an extremely repetitive motion. And it's there's a high focus on like perfectionism. It's one of those things where like you never do it perfect.
Interesting.
Ever.
Okay.
Like every single stroke has problems.
Wow.
Because it's this fundamental thing where like it's an unbalanced system.
Okay.
Where like just physically the center of gravity is above the like point of flotation in the boat. So it wants to tip over always. So basically you balance the boat with the oars in the water when you're pulling on them, but in the whole section where your oars are out of the water, you are having to maintain balance.
Interesting.
So like every stroke is this like attempt at perfection that's never there. And it's very, for any of you out there who like to overthink things and are perfectionists, go try rowing. It's fantastic. But there was this quote that a coach said one time when we were out on the water, which was, practice does not make perfect. Practice makes permanent.
Interesting.
Perfect practice makes perfect. And so it kind of like leads back into that of like,
and so that's saying doing things like developing bad habits is also a possibility.
If
that's
just basically saying like, if you do the same thing over and over, but you're not being attentive to what you're doing, then it just becomes a permanent bad thing. Like you're really, really good at doing a bad thing.
Like mass production.
Yeah, sure. But if you are constantly improving, as you do this practice, you'll attain perfection, maybe, but never really.
Right.
Yeah. Quick mention of TPS Engineering.
Oh, yeah. So we sort of teased this last time.
I don't know. I've read about it a little. It's been a while, so it's definitely something you would introduce.
Yeah, I mean, again, I want to read about it a little more deeply before I claim to be any sort of expert. I think what jumped out at me as like, wow, I really need to go back and dig into this a bit.
It's a classic Toyota flip everything on its head perspective, right?
A bit, yeah. The things that were really surprising to me. So they produce cars, which are obviously very complicated and safety critical.
Yeah.
They produce a new car design with about half the engineering hours in about half the time. So it's not like they're just growing their team to do it in half the time, or they're literally just putting in half the engineering hours. And then the result is goes through typically fewer revisions before it actually hits like production. Mm-hmm. So they're ending up with a better result in half the time. Another striking aspect is that the team size on most projects in most companies starts off small. Think a couple people in a room coming up with a cool idea. Then it gets bigger and bigger. And as the launch date approaches, it reaches its largest size, where they're pulling more and more resources in to get this thing launched. At Toyota, apparently, I haven't been there, but that's what I hear. It's the opposite. So I would guess, I'm guessing here, but like probably a great new idea comes from a few people or one person who says, "Here's an idea," but from there, their project goes from a large team size at the beginning, the largest at the beginning, and then it slowly tapers off toward launch date.
So that early stage is everybody from every system sort of throwing their needs, desires, concerns into the hat and
Yeah.
kind of getting a big picture.
Yeah. And so it's a super slow start,
Yeah.
which I think is why no one does it, because it's like very slow progress. My brief overview is you get all the quote stakeholders, get everyone in the room and sort of go through general ideas on how one might achieve the goal. And then everyone gets to kind of flag potential issues. And then for each potential issue, everyone comes up with mitigation strategies, like how might we avoid this issue? And you go through that on all these concepts. And then you slowly refine to where it makes sense for everyone. And what this avoids, which is really interesting, is rework, right? So there's a huge waste when you make massive progress. And I've sort of been wrestling with this, but you make a lot of progress in a particular direction. And that is perceived by everyone as good, right? It's like, wow, look at us. We're really moving. Sure.
Yeah.
And
that
then
team's just flying.
And then you learn something new that makes you have to redo a lot of that work. And I think there's a temptation, and I've seen this a lot, and I've done it, where you go, okay, well, now we know. And that was such a good way of learning that lesson. Mm-hmm. But I think what Toyota is hypothesizing and executing on is that is something you could have foreseen if you had planned enough. And so like another thing they talk about is like 90% planning, 10% execution, which is pretty wild. But people who implement that, like some shop tours I've watched, there was a company, I think they're in the UK. They, at the beginning of COVID, wanted to go into medical stuff, and it's something they're still doing. So it wasn't just like a flash in the pan. Yeah. But they built their clean room. People said it would take them a year minimum. Right. I think they built it in a month.
Wow.
With a ton of planning. Like every single system was planned out exactly how it was going to go. Yeah. They put in a huge number of hours up front. And overall, so it's interesting because I think you have to have a lot of faith, sort of, and a lot of support from management because you show very little progress to start. And so I think there's a hard anti-incentive here to, show me something,
Right. You got to have philosophical buy-in, basically, on all sides of the company.
But again, like half the engineering time for a better result, bigger team at the beginning, and tapering off as you go, 90% planning, 10% execution. Like those are all things that I kind of read and I was like, that is different. I need to know more about this.
Yeah. I struggle, or not struggle. I deal with balancing that a lot. I find, especially around like fixture building for more complicated projects, of the execution is pretty resource and time intensive, especially if you don't plan it out well. And so I'm always balancing this like extreme hesitancy to start before I have it fully baked in my head or designed to a way that I'm fully satisfied with. Yeah. But also trying to balance like not pushing things back too far.
That's the thing.
Somewhere in the middle, at least in our applications, we don't have huge engineering teams, and we're also responsible for production. So
I think there's that. I think there's also this, like, I do a lot of prototyping, or did a lot of prototyping for startups. Yeah. And there's a huge risk. The fewer touch points you have with potential paying customers, and ideally actually paying customers for your crappy prototypes, right? The fewer touch points, the longer you go between those, the bigger your risk becomes.
Of losing them?
Not of losing them, of being wrong. Right. And investing a lot of time in a direction that turns out to be incorrect. Yeah. And so I think like a lot of what they're doing, there's this element, like when Lean came to the US, it was almost named Fragile rather than Lean.
Well, isn't that actually what Toyota initially called it? Was it the Fragile production system?
Something like that. Like it's meant to break and show you where it's weak. And I feel like in a similar way, if you execute that idea halfway, it's not going to be better. So, but I think really interesting to think hard about what they're doing, and I just want to learn more about it.
Yeah, I think they're like the fail fast, fail cheap mentality has merits. Figure out, because sometimes I think I think trying to just put it in context in my own head, I think without a huge engineering team, sometimes you're not going to find the issues until you try.
Yeah.
So I think that has a merit. Conversely, if you have a lot of experience and you are, I'm putting this in the context of small shops like ours or small outfits. If you have a lot of experience with whatever you're doing and you can think through a lot of the potential pitfalls, I think you will be better off waiting until you have
Right.
a fully baked solution.
I think so. I think there's
execute.
I think there's a hybrid, like you just said, fail fast, fail cheap. I think that's what everyone talks about, but very few people actually achieve.
Yeah.
So in a prototyping process, I think it's really important to identify exactly what your current risk is. Is it market risk? Is it technical risk? Is it manufacturability? Like, what's your risk? And then go prove out just that. And I think the mistake of often people is building a prototype that does all the things, even though you really only need to know about one of them. An example of this would be building a working machine where people are going to buy it based on functionality. Like I was working with a group who was doing this, a machine. And I was like, okay, here's what you should do. Build a nice looking box, put a person in the box and have the person inside do all the function and just go test it and see if you can sell it. Cause you're going to they were like, do we use a conveyor belt here? What type of conveyor belt? They're kind of expensive.
Yeah.
How are we doing? Like, what's our vision system? And it's like, guys, like, you don't know if anyone's going to buy this. Of course they didn't do it.
Right.
But that would be like the risk there was a market risk. Like we know we can, the technology exists. Like you're going to find the technology to do the things you want to do.
Yeah.
Yes, it's going to be some engineering time, but like it's a market risk. And so I think like fail fast, fail cheap, like keep it really fast, keep it really cheap. And then you can still be in that paradigm of de-risking small chunks of a project.
Yeah.
And slowly narrowing in on a viable from all, like in all ways, solution that you don't have to rework.
I do think a lot of people try and fail fast, fail cheap on the whole package instead of boiling it down to its component pieces.
Yeah.
Which is something I really appreciated watching you figure out systems and just little aspects of your process. I'm definitely guilty of wanting to solve the whole thing in one go.
Yeah.
And sometimes watching you be like, well, I just separated out this one little piece and I tried it and that worked. So I think this can go. And I'll be like, oh.
Yeah. I feel like once you find the crux and you're like, this is going to be the trick.
Yeah.
Let's see if this piece works. And then,
Cool. Cognitive load. You talked to a professor.
Yeah. Well, that wasn't a very brief summary of TPS engineering. Let's try to make it quicker on this. So we mentioned cognitive load last time. Or cognitive workload, which is something that's not really explicitly talked about in a lot of this literature, which I've just found striking now that I've kind of like dug into it a bit. So I spoke to my college professor who taught Psych 101. I remembered he had this problem. I think I mentioned you pick digits 1 through 9.
I don't know if you did.
Oh, so if we take turns picking digits 1 through 9, and you're trying to add them to 15, it's a pretty difficult thing because you're trying to add yours to 15. You're trying to remember what I've picked already and make sure I can't get to 15 with my next pick.
Oh, interesting.
Right. So it's pretty hard.
Yeah.
Turns out there's a visual representation of that where you're basically playing tic-tac-toe. So if I'm playing as tic-tac-toe and you're playing as this like, like arithmetical version, I'm going to win pretty much every single time.
Because tic-tac-toe is easy.
Very easy.
But
we're achieving the same task.
Interesting.
Right? We're both going to end up with, I'm going to end up with something that adds to 15 very easily with very little thinking. So I remembered he had presented that problem and I couldn't quite remember the rules. So I just wanted to reach out to him. When I looked him up, turns out this is sort of his field of expertise. Like this is what he's researched.
Interesting.
So set up a call with him. I'm going to dig into this further because I think there's like a lot here that needs to be figured out. So they created a problem, like, the towers of Hanoi. It's like 3 poles on a table in front of you, and you have rings of smaller size, like bigger to smaller on the left, and you have to get them all the way to the right without putting a big ring on a small ring. Yeah. So that's Tower of Hanoi. So they called it problem isomorphs, where you can take the same problem with the same available like number of moves to a solution, same like problem space,
sort of a control basically.
Well, just adding. So they came up with the monster problem. So you have 3 monsters, and the one on the left has to pass its gloves to the ones on the right, but you can't pass a monster a glove that is bigger than the glove the monster is currently holding.
Okay.
Same problem, really hard to hold in your head.
Uh-huh.
And they could just keep adding layers. And they got to a 15-to-1 ratio of
15-to-1 ratio
time it takes to solve these problems, even though it's exactly the same problem at its core.
uh
So Towers of Hanoi, you look at it, that you tell them what the task is and what the rules are. It's very clear what the current state of the system is, whether you're breaking the rules, whether you're in compliance,
yeah.
all that. When you start explaining the monsters thing, that is a weird game, and you have to remember what. Anyway, so yeah, so one group,
Glove
I think it
size
took
and
them
monster
around
hand size and all the
all those things.
Okay.
So it took them, the control group, I think around 3 minutes to solve. They reduced the number of rings to 2, I believe.
Okay.
So it was a total of 5 moves to finish. And then the monster problem in its most complicated form took 45 minutes.
Wow.
And I think that there's a ton of stuff that we do every day where we're more in that 45-minute group where we've made it really difficult for ourselves. An example in my shop, which I mentioned last time, is we have to update the tool length in our CNC.
Yeah.
When we put a new tool in, and we're constantly changing the gripper every time, like our spindle gripper, our automation on the mill, we have to change an element of that, and we have to update the stick out length. And we've arranged it in the shop so that you read the number on one side, and that's a 3-digit number. We rounded it. It used to be a 5-digit number for no reason. I was like, we do not need tenths here, because typically you do care about it to 4 digits after the decimal.
Yeah.
In this case, I rounded it.
Right. It's not going to make a difference in that particular process.
Yeah. So we rounded it, but even so, you read it, and then you literally have to turn around and enter it into a specific table. So if you think about what you're doing cognitively, you're reading a number, you're turning around, so you have to just remember it, and then you have to go into the table in the control, however your brain is doing all that.
Yeah.
Go to tool 14. So now you're referencing a number, because you know you have to go to table and check that you're entering the data into tool 14.
Yeah.
So now you're holding 2 numbers in your head, and then you're typing in a number to that. And then very often, because this is really important that you get it right, you go and you turn back around and you check it again, and then you turn back around and you're reading the number that's there, comparing it to a number you've stored in your head.
Yeah.
Our brains are very good at it.
But still
just because you can doesn't mean you should. It's just such a waste of mental capacity. And like we talk about the 8th lean waste of wasted human potential.
Yeah.
Such a waste. And I think it takes a big toll. So there's like mental fatigue over the course of the day. And just I think there's a lot of really interesting follow-up information. There's also seems to be a linear relationship. There's another guy, I'm forgetting his, Saul Somethingberg. If you give someone like a number of digits to remember in their head, and then I give you a probe number, and I ask you to tell me if that's present in the set you've memorized or not. There seems to be a linear relationship of how many numbers you're referencing.
And how accurately you can identify whether they're...
So accuracy does go down, but also, so it seems to be about, I think it was 4 milliseconds per digit. Implying, and so like, I don't know, like as we make our life more complicated, you're remembering a whole email address that you then have to switch windows and enter that in. Like that is not only silly, but it's like, it's pulling you out of thinking about what you're going to write. It's pulling you out of a lot of other stuff. And at the end of the day, when you feel mentally fried, Anyway, so that's sort of the overview. Definitely a lot more information.
What was so there was, you were saying a 15-fold increase in complexity resulted in
15-fold increase in time it took for people to solve a problem.
Based on
based on increased mental load. I don't know. I haven't read the paper on specifically how complex the mental gymnastics were. There was some really interesting,
but it's not
nuances there.
Linear-ish,
I don't know if you can. The really interesting part to me is right now there's no methodology of quantifying mental load. There's sort of just self-reporting, which sort of makes sense because each person's brain is like better at certain things and worse at other things.
Yeah, we do things really differently.
Yeah. So like I think it would be difficult to do it, but I also think that it would be worthwhile to have a way of scoring. Yeah, because I don't know if they can speak to the relationship of mental load to increase time. I think they're just saying, look, we found a massive increase in time.
Yeah.
Um,
Interesting. Yeah, that kind of really puts into perspective the challenges I was having with my digital job board. And because it was one of those things where you couldn't see the whole thing. There was like scrolling left and scrolling up and down in each column
while like keeping stuff loaded in your brain.
Yeah. So I'd be like, okay, look at this column. Okay, that's a high priority. I think that's higher priority than this.
Let me scroll
And then
over.
I'm going to scroll over,
Oh,
look at this column. Okay, how does this okay, this is a higher priority than that one, but lower than this one.
Interesting.
This is higher than that one.
And if you look at that task from the outside, it seems like a perverse experiment.
Yeah.
Right? It's like, all right, let's have this guy try to hold all this stuff in his head while scrolling back and forth because the screen isn't big enough to see both.
It's like
but I think we do that all the time, and just no one is like,
yeah, it's like the acrobats who juggle the plates on the
right
on the sticks spinning
Can
around.
They do it?
Got one on their nose and
one
in each hand and one on a foot. Yeah.
I heard I forget who was saying this, but there was a good interview I heard. Someone asked how many projects he likes to work on at once because it just seemed like he was doing so many things. And he was like, I've discovered in my life that I'm a 5-ball juggler. And he's like, no matter how skilled the juggler is, there is a maximum number of balls. And when you throw one additional one in there, they all hit the ground.
Yeah.
And I think that everyone recognizes, right? There is a line at which you can't hold all the information in your head and still make do useful work. And at that point, everyone goes, oh shit, I need to come up with a better solution here.
Yeah.
But yeah, there's a lot of room. But the second you are below that threshold, I think there's sort of just an acceptance or total non-recognition of the cost.
Right.
And so we just keep on keeping on.
Yeah, it really puts multitasking in perspective and why we probably shouldn't be doing that. I really kind of took pride for a long time that I was like, oh yeah, I'm getting better at this. I can like
hold so many things up in the air. And
now I'm like, no, I'll do one thing at a time. There are things that I find like I actually really enjoy being a machine operator, running multiple machines at once because it's kind of like this fun challenge of like multi-process flow.
Right.
But you're not also trying to solve bigger problems.
Yeah. And I think your performance and satisfaction would degrade if I asked you to numerically like calculate digits of pi while you were doing it, right? And then you'd be like making mistakes on the mill. You'd be forgetting where you were in your mental task. And I think we end up designing our processes like this. I actually color coded my grandparents' kitchen recently.
Yeah, you were telling me about it.
Yeah, and my grandfather, an unexpected. So this was actually for caretakers because my grandmother had hip surgery, and so they needed to have someone come in and like help cook a bit.
Yeah,
they keep a kosher kitchen, so it's a little bit complicated in terms of like what you cook where and which dishes to use. So we color coded it. The unexpected result is now my grandfather, who's sort of cognitively not as can't remember where to put things. Suddenly can work in the kitchen again. And now it's led to a bunch of hilarious. I got an email from their friend. They're all in their 80s. I got an email from their friend afterward with ideas of like follow-up improvements. She was like, I love what you've done. Here are a few ideas. And I was like, yes, continuous improvement. And my grandmother, I just talked to her yesterday. She was like, yeah, I moved the olive oil like across the kitchen and that's been such a big improvement. And now got me thinking like, she's like thinking about removing, they have like a stacked oven. They're thinking about removing an oven and putting a fridge there just to like reduce the amount of travel across the kitchen to retrieve things. And I was like, this is so cool. But I think it speaks to like this cognitive load idea. He has decreased capability. Yeah. And so this has helped him get back across that threshold into a workable area. But I think we all like, just because we have that capacity does not mean we should be using it on really trivial, stupid stuff. Yeah. But I think we are. Yeah. And so anyway. Cool. That wasn't brief either.
I think we should probably rename this podcast the Not So Brief Podcast about many things. So yeah, single piece flow. We've talked about this. We've mentioned it a lot. Probably a lot of people are familiar with the term at the very least. And probably fairly familiar with what it might look like in a shop. Mm-hmm. I think fewer folks are kind of aware of like the goals you're actually trying to achieve potentially. Yeah. I sort of stumbled into this by accident. I guess it would have been like 2016-ish, 2015, 2016. I was just starting to mess around with CNC work. This was before I was even on Instagram, and like there was basically like 3 or 4 people on Facebook that were machinists
Oh, crazy.
who I
Yeah.
could kind of like bounce ideas off of. And I saw it mentioned, and really for me, which is kind of interesting looking back, um, I found setups and proof outs to be extremely stressful
Mm-hmm.
because I was not a very good programmer and didn't really know what I was doing.
Yeah.
And so I found that doing one setup for a
Right.
complete part really reduced my stress level, and that I could move on to other things sooner. So versus kind of the more traditional method would be to like program operation 1, proof it, then run operation 1 and program op 2 while that's running, kind of a
Oh,
thing.
really? Okay.
Um, and then there's all the other benefits that come from that of reduced defects, et cetera, et cetera. So like I kind of like fell into it backwards of just being like, oh, some cool kids are doing this. Oh, look, it's less stressful. Cool. And then over time have kind of realized many of the benefits. Um, so let's see. Basic concept would be that
Uh,
one piece of raw material, whatever you're producing, goes through all of its steps in sequence from raw material to finished product,
shipped.
shipped product, ideally without delays between processes and not necessarily in groups with other products. You can have many products moving together. That would be multi-piece flow, but for the sake of this conversation, we'll just talk about one.
Yeah, and so like batch work is the flip side of that,
Yeah.
and batch work is what most people end up doing.
Yeah. So batch
And whether
work.
that's batches of 1 or batches of 100, most people are somewhere. I mean, I think most of the, like, obviously, like Ford was doing batches of, I don't know, thousands and thousands.
But they were also doing, I mean, an assembly line is inherently single piece flow.
Single piece flow on their assembly, but
Yeah.
like when they set up a die, which would take like sometimes multiple
Sure.
days to punch a particular part of their car, they just run a lot of those because it took them so long to get it running.
Yeah.
And then move them all into a warehouse, put them all on shelves, pay someone to build the warehouse,
Yeah.
pay someone to manage the warehouse, pull parts out. Some parts get dropped. Some parts get
Yeah.
rusty. So there's a lot of rework coming out.
It is interesting though that like, Ford was kind of halfway there, and that the assembly line is sort of a model. It is like a single piece flow model that has then been kind of adapted to all other aspects of production, manufacturing, now engineering, data flow, etc.
So Goldratt, Eliyahu Goldratt, writer of Critical Chain, he said that like Ford focused on flow by applying a spatial constraint of the production line.
Mm-hmm.
Like you can't overproduce because there's just the car in front of you, and that's it. Now they didn't carry that through. They didn't propagate that through their whole process. Toyota limits their like to achieve flow. They use the Kanban card, which basically suppresses. It's an inventory constraint.
Yeah.
And then Goldratt proposes a stock constraint where you don't release stock to the top of your production line. Which I think has some other issues, but I'm sure I just don't quite understand what he meant. But I think so. Basically, batch work is very tempting. And what I've found over and over through refining certain processes is batch work seems to me to be the result of long and uncertain setups, like that your setup time is too slow. And that's what leads to the temptation of batch work. I think it also touches on this idea of local optimums, where in station, it feels so fast to bang through a ton of work.
Yeah.
Right. Just like execute the same 3 moves over and over. And you just go from a huge pile on the left of all your stuff that you need to process to a huge pile on the right of all the stuff that's already done and ready to move on to the next step.
Yeah.
So single piece flow would suggest that you should pull one piece of stock, you run, and there's examples on YouTube of people applying this to cabinet shops. So you take a single piece of wood, you run it through like the jointer, planer. Then it goes to the chop saw, table. I mean, I'm making this up, table saw, whatever, and then into the gluing, clamping machine. So most people are doing a bunch of cuts on the jointer. They're running all their boards through the jointer, then all the boards through the planer.
Yeah.
And if you look at each station, it's much faster.
Yeah.
But the second you go to single piece flow, and you can just look this up. Maybe we'll put a link. But people often increase their production by like 150% with no training, no changes in any other way, just moving to single piece flow in a normal shop.
Yeah.
And that's before optimizing the machines to reduce transportation time between machines, right? The machines are spread out often because you need space to stage all the batch work. So you have a huge cart that you then, run all your stuff, stack it on a cart, push it to the next machine.
Yeah.
Do it again. Anyway, so it's really interesting. So single piece flow, it's just take one piece and get it through every step of the process. And any deviation from that points at a new place to refine your process, I think.
Yeah. I'm trying to think of a way to put this in generally. I'm sure most people who are listening are machinists, but for those folks who are not, just trying to put it into like a universal context, maybe like doing dishes would be a good example. Like if you,
kitchens.
If you have a whole bunch of dirty dishes, staged, the classic example that I think most people do would be you put everything in the sink, then you scrub as much as will fit into the next sink, and then you rinse all of that as a batch and put the stuff into the drying rack.
Yeah.
And single piece flow would be to take a dirty dish, scrub it, rinse it into the drying rack.
Yep. And things.
So the temptation for most of us would be to say, well, that is slower in station. Like if you're envisioning just the sink as the station. If you were to put this in the larger context of getting dishes back into the cabinet, like put it into a restaurant context, for example, outside of a home, if you assume that dishes need to be available to go back out onto the floor with new food on them.
Yeah.
Getting a single dish to the drying rack and dry is going to, you're going to have more dishes available at all times that way.
So there's much larger effects to that. So it's something I've thought a lot about. We just moved into an apartment that doesn't have a dishwasher.
Yeah.
I've installed dishwashers in every place we've lived so far, including in my dorm room in college, because I just don't like doing dishes. But what I've discovered is that is batch work, right? So now you're optimizing your whole kitchen layout to fill your dishwasher with dishes.
Yeah.
And you need to have enough dishes that you can fill it with dishes and still be using dishes, and then run it, and then empty it into your cabinets. If you eliminate your dishwasher, which is a huge batch of stuff, and you wash as you go, you suddenly need a lot less cabinet space, which means that you need you can have a much smaller kitchen, which means that when you walk from the fridge to the stove, it's a shorter distance because you don't need as many cabinets to hold all the dishes that you need to get you through the batch of a dishwasher.
Yeah.
Similarly,
you just have to commit to actually washing your dishes every
totally. And this applies beautifully to lean, which is that commitment. If you slowly reduce the number of dishes you have in your system, any deviation from your optimum, the best way you know how to do dishes, is going to result in a real failure. Whereas most people, and this applies to restaurants too. My brother's in restaurants, so we talk about this all the time.
Yeah.
Most people's reaction is to say, oh, we ran out of dishes today, we have to go get more dishes.
Yeah.
Right? Not rationalization, which is, okay, we ran out of dishwashers. Where are those dishes? Oh, they're at the sink. And meanwhile, they're running batches of cleaning all the pans because they want to use I'm making this up, but they want to use the pan rack that goes in the industrial dishwasher. They have all these different styles of rackers. They're running pans right now. So I'm, again, making that up, but if they optimized for availability, like I was sort of wondering if stations, like if you think about a restaurant kitchen, I think, and I'm not an expert on this, but I'm guessing they have enough storage in their dish pit for all the dirty dishes that they might see at peak. and then they,
Hope
or
maybe.
close,
I don't. Yeah,
maybe not peak, but say 80, 90%.
that seems a lot of forethought for restaurant
I mean,
people.
this is probably what it results in. I don't think it's proactively thought through, but I'm
Yeah.
guessing they're like, we need this much space,
Sure.
right?
Yeah.
So they have the space designated there. Then they also have the space for all their clean dishes set aside somewhere else in the kitchen.
Yeah.
If they were dedicated to getting dishes through the dish pit, or if when a cook on the line got a recipe, got an order in front of them, if they triggered washing the dishes at that stage so that the clean dishes met them when they're ready to plate, they could eliminate probably 10-20% of the storage that's dedicated to clean dishes. And the number of clean dishes that they need in their system is because they are batching their dishes.
Yeah.
And so it's huge. I mean, the waste is tremendous. And most of it's very easy if you don't think about it really hard. The obvious solutions are increase the number of plates you own.
Yeah.
Get a faster, more expensive dishwasher. All that stuff. And suddenly it's like, oh, wait, if we just wash these one at a time, we need to own fewer dishes.
Yeah.
I don't need 7 measuring cups. I only need 1 measuring, or 2 maybe, right? One thing I'm doing in the kitchen is converting a lot of our recipes to weights.
To weights? Oh.
Because you don't dirty as many dishes. So then you don't have to wash as many dishes, right? You just put a bowl, you tear the scale, you add your whatever, tear it again, add the next ingredient, and then you have fewer dishes. There is a constraint around volume, like teaspoons and tablespoons don't really.
Yeah.
The accuracy is not high enough. But anyway, yeah. So single piece flow is hugely powerful and reduces a lot of other wastes.
Yeah.
And I think every time I've seen we are batching, it's because of long setup times. I have a really specific example, which is cutting webbing for sewing onto our straps.
Yeah.
There's still this very deep temptation to cut the webbing in a batch. And I was thinking about it 2 days ago. I was standing there, I cut one, and then I was like, no one's watching. I'm going to cut more. No, not, but it's like, fuck, I know I shouldn't, but I am. And so I was thinking about it, and it's because the webbing cutter takes probably 8 seconds to heat up. And so you're
just standing there for a second.
You're standing there for 8 seconds. So that's one of the lean waste is waiting, right?
Yeah.
So I'm waiting on the machine to warm up so I can process this thing. So there's a lot of clever solutions.
Yeah.
Right? Can I have it preempt and turn on ahead of time? Can I somehow keep it turned on and not overheat?
The key point here is just being that the single piece flow method highlighted that waste, whereas otherwise you might not be aware of it.
Yes. And if we pushed in the other direction of just embracing that and going let's just batch cut everything.
Yeah.
Suddenly and this is how we used to do it. So we batch cut our webbing, and then we had a whole storage rack dedicated to storing webbing.
Yeah.
Which we eliminated.
Well, and there's the whole defect side, which I think
is huge,
is massive, where
you didn't realize, but you set up your station slightly wrong, and now you cut 50 parts that are a little bit off.
Or to put it in the dishes context, maybe you forgot to wash the bottom of all the plates.
Yeah.
And your dishwasher's not good at getting the bottom of your plates. And now you're in a restaurant and you need 50 plates. Yeah. And you have 50 dirty plates.
Yeah. And I would say all of this is not an absolute thing. It's not you need to do single piece flow.
No.
What you do need to do is look at your batch size and try to reduce it rather than increasing it.
Yeah.
I had another example. I had a job. I was going on vacation. I realized, I don't know why it took me so long, but I realized I had 19 hours of machining and I had to leave in 22 hours. And I was like, and I did just sleep in the shop and I got up every hour. And I thought about making the mill run for 2 hours. But I realized that if I had a batch that did not that went out of spec, I couldn't afford to lose 2 hours if there was all scrap. Right. But I could afford to lose 1 hour 3 times. And so I was like, all right, I need to keep it at 1 hour.
Yeah.
And realistically, it would be even better to reduce that. And I will say we switched, we have a flip station now. So we used to run 40 parts op 1.
Yeah.
And then manually flip them and then run 40 parts op 2. And that had a lot of waste associated with it. And one with defects is just sometimes there would be an issue and we had just run 40 more parts in op 1. And so we couldn't, now I can open the door of the CNC at any point. And sometimes I do when we're having an issue with a particular part, it just hasn't been running properly or something, and that happens sometimes. we can just pop it open at any point in the cycle, and we have a freshly finished part that ran op 1, flipped op 2. So it's complete. We can look at it when we're proving out new programs.
Yeah.
It's always running 1 in op 1, 1 in op 2, complete. I can do a full test of it. Anyway, it's really
and
impactful.
In the machining sphere, I cannot count the number of times that it has saved me from making scrap. Like, I'm an okay programmer. I don't know if I think I can be fairly creative, but I'm maybe not the most like super detail oriented, like I'm going to nail this the first time I post the code kind of programmer.
Yeah.
I'm always generally making some tweaks, which I should probably work on reducing, but it's very easy to overlook sometimes little depth, often it's a depth thing, flipping from one side to the other. And you're like, oh shoot, I didn't make that.
And I ran a lot of them.
Yeah. So I have a hard commitment to single piece flow wherever possible. That breaks down on our lathe right now. I'm kind of rethinking maybe how we'll try and approach that going forward.
Yeah. And so that's the difference there is you realize the power of the reason to achieve single piece flow. And so rather than saying, okay, we have constraints on our lathe, so we just run bigger and bigger batches.
Yeah.
It's like, what can we change here fundamentally? And like sometimes the effects and the costs are so high that it really opens up the budget to solve the problem too. Mm-hmm. I think.
Yeah, there's other benefits as well. Like we've talked about there's the availability thing we talked about, like not waiting on a batch. So shorter runtime, shorter overall processing time for a part. So potentially you can get stuff to your customer sooner, get paid sooner.
And to quantify that, if you reduce your batch size by a factor of 10, you typically cut your lead time by 80%.
Yeah. And then another goal or another benefit, and I had this happen this last week, is a customer was really hurting for their parts. And we were able to ship them. We're only a half a day into the job of a 6-day job,
finished parts,
and we have finished parts we can send them to just hold them over for the next week until the rest of the parts were done. That's a huge benefit that you're offering your customers. That is maybe hard to quantify, but it's very tangible.
Yeah.
And I'm not even charging them necessarily for those parts that I've shipped, but they are happier. They can continue their business more effectively.
And I think something I didn't realize when I started this, but if you look at parts sitting in your shop that are halfway complete, they represent the cost of materials that you cannot sell. They also represent time on often a machine that is a constraint in your process for other stuff that you need to ship. Mm-hmm. Right. So if you make 30 of something and you're like, wow, look how much inventory we have in this thing. Oh, we can't complete that order because we're missing the product that person ordered.
Yeah.
I think a lot of people don't think about the fact that all the inventory sitting on your shelf represents time that obviously was poorly allocated, right? Yeah. If you could throw those products in the trash can and get that time back and put it into the things that you need to actually ship. Like tons of people have this issue, back ordered product, right? You can't ship a whole order because you're missing one part.
Yeah.
What you forget is that the reason you're missing that part is because you didn't have enough time, whether that's people time, whether that's machine time, to make that part that week.
Yeah.
But you have often hundreds or thousands of hours worth of human and machine time like sunk into product that is sitting on a shelf that has zero value to you presently.
Yeah.
And people look at inventory as an asset. And I think you have to switch your perspective and look at it as a liability.
Yep.
Because it is all cost with zero benefit until someone orders it. And often that's true for some of it. And everyone breathes a sigh of relief. You get a big order and you're like, wow, we can just ship it tomorrow. How awesome. It's like, no, that is not awesome. You've been sitting on that cash. Like your cash turn through your business is really poor.
Yeah. And just one last little piece is that turnaround time is huge for businesses these days. So if you can reduce your turnaround up from an order to a completed order, that's worth a lot of money to a lot of businesses. They will like legitimately pay more to have it sooner.
And to put numbers on that, this is in Shigeo Shingo's book. I forget the name of it. You can achieve, and people often achieve with three things, a 500% reduction in lead time. Mm-hmm. So it is not inconsequential. You have 80% of that is from batch delays. I think you can reduce an additional 90% of that remainder for synchronization, and
Mm-hmm.
then process delays. Those are the three.
Yeah. Interesting.
500%. So that's big. And for us, what that means is, and we are moving in this direction of achieving a state where an order can trigger machining on the mill.
Mm-hmm.
Like someone orders 2 straps, we will machine those parts, we will paint those parts, we will assemble those parts, and we will ship those parts. And ideally, that can happen. And I've counted it out. That can happen in 4 hours.
Yeah.
There's a lot of work to get there. Right now, that is not how we're doing it, but single piece flow can get us there, and it would have huge effects on our shop.
Yeah.
We could reduce the footprint that it takes us to manufacture this one component by probably 50%, which means we would have a lot more space in our tiny shop to do other things that generate value.
And you could potentially have 0 inventory.
Yeah.
Aside from raw stock.
And sometimes this happens. We find a defect, we go to assemble parts, we find a defect, and we're like, wow, okay, how many parts do we have in process that have the same defect that originated at our mill?
Yeah.
And then we have this whole like supply chain traceability question of, wait, did we produce these parts before those parts or those? Like now we have that logged, but it's still time consuming and wasteful. And I'd like to say it doesn't happen, but it does.
Yeah. And so to tie this into a little improvement for this last week, and sort of, I think one of the undervalued aspects, or the aspects of single piece flow that at first are counterintuitive, is because it does at first glance appear to be less efficient, is the highlighting issues and providing a way to refine your process. Similar to that, this is not necessarily a single piece flow, but it's in the context of doing something in a way that at first glance seems less efficient, but it highlights things that you can improve. I started handing off, like we've been talking about it for a while, but the last 2 weeks started handing off tooling and material purchasing to my employee Ariel.
Oh, huge.
Massive.
Nice.
So cool. There was high fives. High fives were had. And at first it's like, I already know the information. Why am I handing this off for somebody to order it? In the process of doing that, it became very clear what information she needed. And
very cool.
I was able to integrate that into our little ERP system and be like, okay, so at the time of quote, I just need to put in who we're buying this from. And then that can flow through.
That's awesome.
She has the information. She can place the order. And it's freeing me up to do programming and the other things that I'm good at. And so I'm not having to hold that information in my head anymore. It's just there. And
that's so cool.
So it was the overall thing was a small improvement, but it's highlighting, I think, a way that we're going to improve a lot of different things. So that was one cool little improvement. I'm just going to run through some of our own stuff this last week. Ariel, she of her own accord modified our job board, which was super cool.
That is so cool.
I was just like, heck yeah. That it consisted of just, instead of everything, so all of our processes we have highlighted red at the beginning, and then we turn them to green as we go. Instead of having a board full of green and red, now she's removing things as they become green, and only the most recent process that's green is highlighted. So there's just much less to try and take in on the
very
board.
Cool.
And it's something we talked about early. We weren't sure if it was going to work, and it's definitely good. Super small 3D printer thing. We used 5th axis centering vise, and it has these counterboard holes so that you can bolt it down to something. But we use the 96 millimeter stud pattern on the bottom. This current job that I'm talking about, where we're running single piece flow and we shipped out parts to the customers, there's a third engraving operation.
Okay.
On the 4th axis would have to happen in a different direction. I was kind of like, I think we're going to reduce efficiency in the program because we're going to add an operator stop, and the operator is going to come pull the vise out of the plate, rotate it 90 degrees, put it back
cool.
in, so we can do that.
Yeah.
That engraving operation in process. There will be delays. but overall allowed us to ship parts.
That's very
So I
cool.
thought it was cool. Anyway, chips fall through those holes. And if they get underneath there and lift the vise up, then you get defects. So we had to be super aggressive with blowing it out with air, making sure it was clean.
Mm-hmm.
You still have to do a little air blow, but I made 3D printed these plugs that go in those counterboards so the chips can't fall in.
Very nice.
Big one is I've been working with our friend Avi on post-processor modifications.
Yep.
I've had a laundry list growing for the last many years and just was kind of outside my bandwidth. So we're not fully complete, but there's a whole bunch of things that we'll go over soon that will allow us to standardize our workflow more, CAM programming and setup workflow.
And opportunities for defects, really bad defects of hand editing code that goes to the CNC.
There's just so many things about it that are bad.
Yeah.
And then what was it? Oh yeah, just we got a second little label printer. Did I mention that? I'm not sure if I did, but anyway, we set up a template. We have a dedicated label printer with these 1x4 labels that we're printing what I'm calling a job traveler.
Oh, cool.
They're just a simple tag that has the job number, the customer, the stock size, and the part name. And then we're just slapping them everywhere.
Wow, that's awesome.
So they're going on the trays that the raw stock that's cut go on. They go on the trays that the finished parts are on. When the actual stock comes in the door from the supplier before it's sawn, we slap these stickers on them so that anybody knows what that's for. And then it goes on the job board so that it all ties back to the ERP system.
Very nice. Something I saw recently that made me think of you is a job shop that they were doing sky rises, high rise buildings, but they used color codes. So they had rotating colors for jobs presently in the shop. They had like 9 colors, and all the paperwork, everything associated with that color, associated with one job was one color.
Oh, cool.
Which I feel like visually would be so quick to know which color job you're working on currently without reading labels and doing all this mental work.
Yeah, we can have like over 50 different individual parts.
Yeah, it might not work.
So that'd be a little challenging, but it's a cool
thought.
Yeah, you want to run through some of your quick ones? And then
very briefly. I spent 12 hours trying to get our 3D printer on Octoprint, which just allows us to 3D print over Wi-Fi.
Yeah.
Looking online, it was like a 10-minute project. For whatever reason, it wouldn't connect to our Wi-Fi, and I just banged my head against that for way too long. So like, they're not all wins. I think that was definitely a poor use of my time. It is done now, and it will improve some other things. This was one I wanted to allow for queuing at our 3D printer because I felt like it wasn't running very much, because if it was running, we were less likely to go CAD up a new improvement for the shop, and because you couldn't complete the task. And so it was like, I'll just wait, and then you wouldn't get to it. So I just wanted to be able to build a queue. So I think that will help in the long run, but just wanted to share, we're sharing a lot of our wins. They're not all wins.
Yeah.
That was one. I mentioned the webbing cutting. And then we had a huge one, actually. So we had someone join the team a little while ago, and it took them probably about 3 or 4 weeks to get up and running on the CNC mill.
Yeah.
We recently had a new person join the team, and it took them 4 days. And so that is huge. And that is all because of systemizing our setups, color coding, and the rest of it. I recently went in and he hasn't hit cycle start without me there yet. Yeah. And we will do an explicit handoff of that. But anyway, so that was really big. And recently huge. I came in and I was like, I explained to him how to check which stock size you need. And he was like, oh, interesting. I was like, wait, how did you do it? He's like, I just pulled the yellow one. I was like, that is awesome. Yeah. So anyway.
Love it. Right on. Well, we're running out of time here a little bit, but let's talk about my software needs. Trying to figure out what kind of this falls under in terms of it's, I guess, just data management. I'm trying to think of like what lean waste.
Well, I don't know what waste it would be, but Toyota has written quite a bit about developing solutions in-house versus outsourcing it.
I guess that's really the crux of the discussion.
And they claim typically it's a fifth the cost, a fifth to a third the cost to develop something in-house. I have no idea how they're accounting for that. I don't know if that includes, I don't know. It's probably, they're pretty rational, but
I think there's some assumptions built into that,
for sure.
which is A, available labor and equipment, and B, like in-house knowledge base and expertise.
Yeah, the flip side is in-house knowledge and expertise. If you've built the machine and it goes down, you sure know how to fix it.
It's true. Yeah.
But also you sure have to fix it. There's
Yeah.
no support.
So within that context, I am trying to refine my whole digital management flow to be a little more in line with what I want. Specifically, the current ERP system I have is pretty good at like collating stuff, but it's not doing it necessarily in a way I want. Specifically, I want to have more templated setup information.
That makes sense.
There's some other aspects about it that are just like took me a while to get my head wrapped around. And now that I do, it's fine, but it's not how I would like to think about it. The other aspect of it is that the quoting side, it's relatively quick, but it lacks a lot of granularity in terms of my costing.
Okay.
I think it's very simple, which is good. And this on the speed side, and I sort of have like a sense for what parts cost and what.
But you have to use that sense.
I have to use that sense. It's not something I can systematize, and it also like it is prey to my bias, I guess you would say.
And it really caps your scalability in handing that off.
Yeah, very much caps it. And I suspect that a lot of jobs I'm under quoting or underbidding because of my inherent fears about not having enough work. Just my whole history of like starting as this little garage shop, and well, I guess technically we're still a little garage shop, but like being like, oh, I really need this job. And now I kind of want to get it outside myself. So I have something that's telling me how much a part costs. And then, so yeah, templating and costing are two things that I really want to improve, as well as just at administrative time overhead. So I'm looking into, specifically, I'm looking into quoting softwares.
Okay.
Some of them are pretty cool. I'm looking at paperless parts quite a bit. It's everything in this business is very expensive.
Mm-hmm.
It's relatively expensive. It does some cool things. It will definitely make some gains. The integration with, it's not an ERP system. So the integration with whatever your like job management software side is, that part gets very expensive, like ridiculously scaled. We talked about this a little bit, but it's 3 times more expensive if you want to be able to fully integrate to another cloud-based software.
Interesting.
Which I found a little strange, since they don't offer the service and they're making you pay an extreme premium to allow you to integrate their software.
Right. And presumably the small packages for small shops.
Yes.
And so if they're trying to grow along, like start people off in who are small and grow with them.
Yeah.
It's sort of hard.
And for a small shop like myself, where maybe I would be like, I'm going to start by buying the more expensive ERP, but then I'll integrate the lower cost.
You may be somewhat unique in having an ERP and a focus on that side of the process at the scale you're at. I don't know.
It's possible.
But also maybe not.
I don't know. Anyway, so kind of what I'm weighing right now is, do I just like buy this off the shelf software, which does a lot of cool automation stuff.
Okay.
And deal with the headache of integrating, or, well, there's 3 options, or refine the current ERP system I have, because it is in Airtable. And one thing I do really like about it is I can make refinements as long I just have to put the time in.
Yeah.
Or with the help of a friend who does some more of this stuff, build out a new Airtable base system that's like kind of stripped down to just what I want and kind of highlight the features that I want. So anyway, bouncing it off you.
Yeah, interesting. I mean, I can see the temptation to each for sure, right? But I think there's one that's going to take a lot of time. There's one that's a lot of money.
Yeah.
And there's one that's maybe right in the middle. I think the advantage of building it yourself would be So that is one of the large savings that Toyota talks about, is paying for stuff that you don't actually need. So
Yeah.
most machines are built for a general audience, but you know exactly what you need.
Yeah.
Um, my suspicion is that building it yourself is going to get you less of what you want now, but a lot more of what you want in the long run.
Mm.
Because the other options, you're a little bit just admitting defeat on being, I mean, not that you shouldn't, but just being like, this is it's built. I'm just going to use this and I'm going to tweak it a bit and it will work. There's a very good chance. And you've talked about this previously, of like reducing friction to making improvements.
Yeah.
Like that would be, if you built it yourself, you're going to have a very deep understanding of why things are the way they are. You're also like going to be constantly evaluating how it could be better, waste that's still built in. And then if you have an opportunity for like a really cool integration with your physical job board or
Mm-hmm.
something, like that's going to be something that's suddenly available, I would think.
Yeah, and I
That
think that's
said,
not to be underestimated,
yeah,
that
that said,
potential.
immediately that is a juicy project to like bite into for sure.
Yeah, juicy or bitter, depending on your.
Juicy, filled with bitter juice.
Yeah.
So that's tough for sure.
It is, and it's also like a little bit outside my skill set. It's like I know the picture I want to see at the end. I think I got a pretty good idea of it.
Yeah.
I've been working in Airtable long enough now that I can do some stuff. I've built little
Yeah.
automations in there that do things that weren't there that I wanted.
I have a question. Is
Yeah.
there a possibility, like, I don't know, like Zapier or some other platform, like, is there a patch you can apply to your current, is that the building another piece in Airtable kind of option of like patching together what you want?
With patching together with what?
Well, it seems like one option is sort of jumping ship to this other way of quoting, right?
Yeah, but still integrating with Airtable,
And then
probably.
integrating with Airtable. I just wonder, is there a specific piece of the puzzle that you don't have now with your quoting that you could systemize in a way that isn't maximally efficient,
Mm-hmm.
but would test your ideas? Do you know what I'm saying?
I think so. Yeah, I think we could. One cool aspect of the paperless parts system is that you can template sort of your different workflows.
Okay.
And so like you'll bring in a part and you can say this is a like a lathe plus 4-axis mill part.
Oh,
and,
cool.
it's got all of your
Okay.
different processes sort of laid out, and
Yeah.
and will fill in times even for them based on its like CAD.
Okay.
What's the word? Interrogation software. That's
cool.
It's pretty cool.
Yeah.
Simultaneously, I feel like we could probably template out sort of those same things, and I would be doing the interrogation. So we would lack that, but it could be fully integrated and updatable. That's the thing, is like I've never had a piece of software that it's like it's just
It's
a
exactly
slam
what I
dunk.
want.
It's it's
Yeah.
similar to the CNC machine thing where it's like a general audience. There's always
Right.
a bunch of stuff there that you're like, I don't need this. And then there's a few things where you're like, why isn't that button there? I really need that button. Yeah.
Interesting. I mean, I would start with, like, it doesn't seem from the outside, and we haven't really talked this through, but I would probably start with building that system, even if it's not quite as efficient because you're doing the interrogation, as you put it, which I don't know exactly what that entails. But like, so it's going to be slightly slower, but I think what it would give you is a deep understanding of what you need,
Yeah.
and what the steps are, and like, yeah, like you were sort of talking about, like handing off the material and tool ordering.
Yeah.
Is like suddenly it highlights all your issues. I sort of feel like it would be a great place to start. Maybe that doesn't cost much.
Yeah. Really just diagramming out kind of the flow.
Yeah. And then it might be, and then you might take another look at some of the expensive software and go like, oh, this is missing a really critical feature that I now know is going to be really critical to me, or not.
Yeah, and also just if I imagined paying myself the additional $500 or $1,500 a month just to work on that, it's like,
oh, yeah, that's not nothing. Or even better, paying someone else,
or even better,
who is better at it, and you can tell them what you want. Maybe.
Yeah. It all of a sudden, like if you flip it on its head that way, not that I necessarily have that time right now. So that's a real constraint.
And there's people who specialize in this, right? Is like Fiverr an option here?
I don't know. I think I would have to be extreme. I would have to do that diagramming step to an extreme degree.
Yeah,
And I think there's a lot of room for interpretation
totally.
in software build out. And also like a high motivation on those platforms for people to just do it the quick and easy way, the quickest and easiest way possible, potentially.
Maybe.
I'm not sure. Yeah.
Yeah.
Um,
I
for the
said to
moment.
someone recently, I want 2023 to be the year of hiring.
Uh-huh.
Just like little stuff. It's like, I could do this or I could hand it off.
Yeah.
And it's like,
Well, more what I have in mind right now is a friend who's recently unemployed, who's pretty
okay.
good at this stuff, who might want, he has kids that he's watching, but
Oh, perfect.
he might want just a little side thing.
Keep his brain going.
Exactly. And he
Not the
loves,
kids don't. I don't know. I don't have
not the same way.
Yeah.
Yeah. And he's really good at workflows and kind of systems thinking.
That sounds like a great option, even if it's just to help you identify exactly what you need.
Yeah.
And then you could go like, oh, that program that costs a lot seems like a lot, but it's going to be perfect and huge. Or it would be a great jumping off point to build your own system. I feel like it would be really informative. And in the meantime, it'll probably gain efficiency anyway.
Yeah.
And insight. So
yeah,
I don't know.
Yeah. Cool. Well, I think that's probably a good spot to wrap up. Is there any last things we wanted to touch on?
Loving the feedback. Please keep sending us messages on what you liked, what you didn't like, anything we could do better, anything we're not explaining. You can reach me at on Instagram at austere_manufacturing.
And you can reach me at Lycan_MFG.
And you can also drop us an email at fixsomethingtoday@gmail.com, I think. Yeah, that's it. Thanks everyone for listening. It's been really, really cool just hearing the feedback and also seeing on Instagram. I feel like people are really improving stuff in ways that I could never have come up with on my own. So it's really fun to see and share, and we can all get better together. So
yeah, indeed. Till next week, have a good one.